Okay, question 2. Which of these is the equation for work done? So just get a pen, blue. So for this, I'm going to need my fat wobbly dinosaurs. And that's because we know that, well, if I've got a box and if I move it, say 10 meters and I have to push it. Oh my God, that's a really dodgy push. We get there, I've just made it worse. And let's push that with 5 newtons. We know the total work, the total energy and energy work are related. Both measured in joules. Is just 5 times 10. The work is the force times the distance. So work done equals force times distance. There we go. The answer is B. On to the next one. A mass has a ball of 0.046 kilograms. Perfect. Don't need to change that. Calculate the change in GPE when it's lifted 2.05. Perfect. Meters is the SI unit. And it tells me the equation to use. How nice is that on a higher tier? So I've just got to shove in the mass, 0.046. Then gravity, I told you got to remember the value for that is 10, and then multiply it by the height. That's it all there. 0.046 times 10 times 2.05. Put that into a calculator, and we get 0.943. And I've got nothing to match it to in terms of significant figures. So, and it doesn't direct me to, so that's perfect. I now release the ball. So I've raised it up into the sky. I'm now going to drop it, calculate the kinetic energy if it's moving at 3.5 meters per second. So go into your equation booklet. The kinetic energy, the movement energy, is half the mass times the velocity squared. And it's the squaring bit that students will forget. So now we can just substitute our values in. I'm going to use 0.5 for my half. My mass is up there, 0.046. Don't need to change it. Multiplied by 3.5 squared. That comes to 0.28175, and I'm going to go to 2 decimal places, 0.28. All of these you should be pretty good at. You've done them a lot with us. On to the next one. It says the ball bounces several times. This shows how the height of the ball changes with time. So I drop the ball, goes down to the floor, then it goes bounce, boing. Then it's a smaller bounce and a smaller bounce, and they've carried on, and then eventually there'd be no bounces. It would stop. And crucially, what have we got then? Well, here, when the ball's in the air, it's got GPE. There's my ball. There's the floor. When it drops, it's going to go to KE. We will lose a small amount of energy as heat energy due to friction with the air. Then the ball's going to squash and gain EPE. And that EPE will go back to kinetic energy, and then the thing will be repeated. And each time we get slightly less. And the reason for that is not all the kinetic energy is going to go into elastic potential energy in the ball. We're going to lose some through heat into the surrounding as it falls, and this ball is going to get hot when it squashes. So we're going to have some thermal energy being lost. Okay, figure 2, estimate the maximum height the ball reaches after the first bounce. So this is me dropping it. There's the first bounce here. Go across, I'm getting roughly 0.9 meters. I'm happy with that. Explain why the ball does not bounce back to its starting height. So we've just said it's this basic idea. Not all the kinetic energy is going to go into elastic potential energy in the ball. Therefore, not all of that will go back into kinetic energy. So we're going to lose some through thermal energy. And it's that key thing that's dissipated into the surroundings. So not all the kinetic energy is transferred into the ball's elastic potential energy stores when it hits the floor. Some of that kinetic energy is transferred to thermal energy, which is dissipated into the surroundings. And there you go. That's that question done. Question 2 is a nice simple one for you.